Never mind. Okay, never mind. I don't want to talk about it. Okay. Okay, so I record the lecture. Okay. This is chapter 1 and system part 2. Okay. The note for parts isn't in e-learning. What do you mean, Hisham? Notes for part isn't e-learning.
The notes for part 2, Doctor.
Yes, if it's not in the e-learning because I'm not lecturing yet, right? Do you realize like last week I lecture
Yes, yes,
first,
I
the
know, but
notes come after.
I thought that you will upload it before the lecture so we can download it and follow with you.
No, I asked you last week, how do I do it?
I didn't attend last week because I had some problems.
Last week I
So
present first because I do like this in contrary with last semester because I think if I give the lecture not earlier, maybe student will not bother to listen to my lecture because they say maybe they think they already have slide. Okay, that's why slide comes after. Okay, Hisham, clear? Comes after. Okay. So okay, where was I? Okay. Last week, okay, not last semester. Already studied introduction, time of signal, and signal operation. Now we go to basic function. So the name is basic means it is elementary signals. So you need to know these basic signals. You need to know this basic signal to solve the complicated signals. Okay, I'm not going to. I think only once I say there is a student fail. Okay, so you guys need to be very careful with this course. Okay, so basic function. So this is the elementary. Okay, then we do the type of system. This convolution will not. Maybe I don't know why it's not here, but maybe in later chapter. Okay, it's not being it's teach, but it's not being accessed. It's not being accessed quiz or test or final. So if you think this is not being this is being teach is in the syllabus but not covered in quiz, test and final, do you think where is this convolution will be assessed from? This convolution will be assessed from assignment. Yes, from assignment. So I will put you guys in group. That's why I hope this week there is no more student coming to my class or going out. So far, no one going out. People coming in. Because I want to divide the group as early as possible because I want you guys have more time to solve your assignment. But if students keep coming in, then it will be problem to not only me, to all of you. Okay. Hopefully this week is the last week. I need to divide all of you in the group. Okay. So now we go for the sinusoids and complex exponential. We'll cover unit step, ramp function, impulse function, rectangular function, triangular function, and sinc function. Okay. So this one, this is a continuous time sinusoid function. We have a cos 2 pi t naught. Okay. Okay. This is mentioned here is cos, and we have sine. How about tangent? Is it a continuous time sinusoid function? Tangent. Is it a continuous time sinusoid function? Can you guys respond in Google Chat? For tangent, is it a continuous time sinusoid function? Yes, the answer is no, because sinusoidal is only in two forms, whether it is in the sine function or in the cosinus. Okay, so tangent is not. I think all of you remember the shape of our tangent graph. Okay, it's actually look like this. I don't really remember, but it look like this. Okay, this is tangent. Okay, so then repeated. Okay, so this is tangent. So it is not a continuous. Okay. Next, okay, next, I have to divide the screen. Okay, don't worry if it's not visible to you. Okay, so we have here a function f t. Okay, then you have what they call here a cos 2 pi t naught. Okay, plus theta. Okay, so here is 2 pi t naught. So you learn also F frequency is actually the inverse of your complete period. Okay, complete period T naught. Okay. Okay. And then somewhere I think in secondary you also learn about omega. Omega is what? Omega is 2 pi F. Okay. If you put this inside this, you will obtain 2 pi over T naught. Okay. So this one. Okay. So this one is just amplitude. This one is a shifting. Okay. Okay, so now we go for the then we go to here. Okay, I hope this one is quite straightforward. Okay, if you have question, you can ask. Okay, then we go to the next one is the exponential function. Okay, I see many people left. Maybe they accidentally left because of the internet. That's why That's why for me it's okay. That's why you students please remind me. Okay, to record. This is not only helping you, maybe helping your friend also, because they maybe some of them maybe access the lecture using mobile data, so they are on unstable network. Okay, if I record, you benefit, mean you can revise, and you are also helping your friend. But please remind me, okay, in case I forget to press the record button. Okay, so now we go for the exponential function. This is a continuous time function. Then you have the exponential function here. Okay, so you have a epsilon exponent. Then you have a damping rate here, a small sigma here. I'm not sure it's visible. I think it's visible. So this is the real damping rate. Okay, this is j omega naught. So this is the imaginary part. Okay, I think you guys know, right? This one is imaginary part. This is the real part. And then you omega, is in unit of radian per second. I think this is quite straightforward. Okay, straightforward. And then this one, okay, this one. I teach the other section, this one and this one, but never mind. Okay. Okay. So let me go for this graph. Okay. For example, let's say we see this graph. I just want to do some refresh as well. Okay. So let's say now we have negative 4 sine 200 pi t. Okay. This is the initial sine graph, initial sin graph. Okay, sinus graph. Okay, this is the original. This is the modified function. So can you guys show to me? Can you guys type in Google Chat what is the operation? What is the operation involved in here? What is the signal? What is the signal operation involved here? There are how many? I mean, there are two. So what is the signal operation involved? What is it? Two, yes, but what is it? Don't worry if you get it wrong. Don't worry, because wrong. If you getting wrong answer in lecture, it's okay. Then in the quiz, I think maybe it's also 3. Yeah. I think it's also 3 here. No, it's not really 3, it's 2. Okay, because this is sine, this is considered a function. Okay, this is considered a function, this is sine. Okay, you guys can continue answer. Okay, so if you see here, they actually involve here is amplitude inversion and involve amplitude scaling. Okay, amplitude inversion and amplitude scaling. Okay, let's say if this one is sin function, this one is sin function. Sin function should have 2 pi ft. Okay, sin function should have 2 pi ft. This one. Okay, should have this function 2 pi ft. But if you have this one theta, mean there is like time shift. Okay. Okay, so the answer is amplitude inversion and amplitude scaling. Okay, so we then the next part is okay, this is the damping rate. Okay, if you see this is a signal with a damping rate. Damping rate is shown here, this one. Okay, shown this one. So, and then shown here the damping rate. Okay, so this is the graph shown the example of damping. So one of the real life application of this damping, not real life application, you can natural. Okay, it's man-made but happen naturally. So let's say you have a base station. Okay, then you have a signal. Okay, then you have a distance. Okay, distance, let's say distance, let's say by x kilometer. Then you have signals coming from here. Okay, coming from here, let's say from the side view. Okay, if you, I think you guys know electromagnetic wave is actually combination of E field and H field, right? So this is the actual signal, but we don't want to headache our head. We just want to see from side view. Okay, so you will see that actually from side view, this is the signal. Okay, ideally, sorry if you heard sound. Okay, because my neighbor is doing renovation, I think. Okay, so this is the real the ideal, but in real life this is not the real case. The real case, it is with damping. So initially like this, and then the signal will be going some delay, whatever, then it's going to be smaller until it's actually become zero. Okay, let's say imagine this one is the bisingnya dia. So imagine this one is a handphone. Okay, imagine just a handphone. Imagine handphone. So let's say Wei Kang is accessing phone right now from here, and then Florence from here. Okay, Florence and Wei Kang from here. So which one will have better signal? Is it Florence or Wei Kang? Which one will have more better signal? Is it Wei Kang or Florence? Yes, good. The answer is Wei Kang because the signal is greater here in strength. Okay, energy strength. The strength is better here. The Florence is very far. Most likely, sometimes she listens, sometimes not. Okay, so this is damping. One of the example of damping in real life. Okay. I think the rest, if you guys don't understand, please ask me. Okay, this one is exponent. You see, this is, there is a negative here. Please see, please very focus. There is negative. So there is like, what is the shape of the? Okay. What is the original shape of exponent? Is it this one? Or is it this one, the original shape of exponent? Which one? Is it A or B? Okay, correct. The answer is A. And then that's why you see here, there is negative inside here. If there is negative, mean your what is it, this one? Sorry. Exponent is time what? Time inverse, time shifted, or time scaling? Is it time inverse, time shifted? Okay, yes. It is time inversion. Good. Okay, thank you for answering. I see that. Okay. Now we go to the next part, which is the unit step function. Okay, unit step function. Okay, so it's employed to switch other signal on and off. So unit step function, you see here, u tau equals to 1, 0, tau greater than 0, tau is less than 0. So where tau is actually the independent variable. Okay, independent variable means not depend on other variable and is a linear function of time. Okay, so forget about this one. You guys can see the example later on. Okay, I just want to show my explanations. Okay. Interrupt me if you don't understand. Okay, so this is the original. Okay, the original unit step function like this. So the amplitude 1, and then okay, I like to remind student. Okay, please write properly. T. Okay, it will be a bit slow, but you know, there is mark for this, even though it is it's, yes, it's slow, but there is mark. Okay. Where is the just now there is lecture? Okay, so unit step, where is it? Okay, xt and ut, sorry, this one. Okay, so ut, so unit step function ut. Okay, so this is unit step function. Before is 0 and then 1, and then let's say if there is some time shifted, let's say u t plus 3. Okay. Okay, so is it the signal will be, the new signal will be this one, or the signal will be this one? Is it blue or green? This one continuous. Okay, continuous. So ut plus 1, ut plus 3, is it green or blue color? Which one is the correct one? Okay, correct, because it's green. Okay, it's green. So last time I put in the lecture, right, my recorded lecture, it's a bit slow, but you create like this, ut minus, and you put like this. Okay, if you do it like this, yes, it's low, but it's, you will do less mistake. Okay, so let's see, -3, so it's -3 here. Okay, it's not here, but if you do like this, sometimes you nervous in exam, you know, or whatever, you cannot think properly, then you do like this, then finish all of your answer, maybe you only get correct here. Okay, so we go for this one. What is this? Okay, I don't intend to make this because okay, you guys can try this on your own, but I will make it a bit a bit simplified because it's too long there. Okay, so let's say we have now the I'm changing screen. Wait for what? I'm changing to my touch screen. Okay, you guys can try this at home. Okay, you guys can try this at home for the complete graph. Okay, so now we have a xt. Okay, question xt 3u t plus 3. Okay, t plus 3. Okay, you see, put minus, and then you have another u t, and then you have plus 3 u t minus 3. Okay, I don't write full. Okay, it's actually 4 there, but I only write this. Okay, Panjang sangat this question. So I only write 3. Okay. Now the next is for you understanding. For if you guys if you guys sure that you can remember and can identify, not do mistake, is okay. This one is slow step, but it will save you. I mean, you will get answer most correctly correct. Okay. See here, you put the bracket awal-awal. Okay. But if you guys remember, no problem. Okay. Don't, if you remember, if you think that you able to distinguish it on site and will not do mistake, no problem. You can just skip. Okay, this step. So this is the correct one. Okay. So here is actually -3. So if we put this one as the graph number A, this one is B, and this one is C. Okay. Okay. So the first one, the first A, okay, the A, okay, the A. What happened to the unit time? It is shifted to the left. Means it is advanced. So it is here. Okay, I choose different color now. Okay, here. So it will start at -3. And if you notice, it is a scaling. So like what I told, like what you guys also told, you guys answering my question before just now. You said set soft inside first, right? So you solve inside first, which is time element first, then you do the amplitude, which is at the outside. So here -3, then here is your 3. Okay. Then the next is your B. I use different color. This is your B. Okay. B, then this you see there is a negative here, but the unit step function is just the same. So this is actually an amplitude scaling. So there's amplitude inversion. No operation on the time and no operation on the amplitude except amplitude inversion. So you have inversion there. So it starts from here down. Okay, so it's a -1. Okay. And then after that, for C, you have minus here, then 3, means it is delayed. Okay, we use what color we use now. Let's say I use this. So it's delayed by 3 here. Okay, then it is 3 here. Okay, then after that, use solve this question. You can try at home. Okay, because I have limited of screen. Okay, then you can then after that you add them together. Okay, you add them together. Okay, you add them together. Like you need to make a specific specific like this. Okay, if you see how many operation involved at what time, -3. Okay, and then you have what, 0, and then you have what, 3. Okay, so from A here, from 0 until 3, you only have 3. So the answer is 3. Okay. And then from 0 to 3, what you have? You have -1 and you have 3. Okay. So -1 plus 3 is what? -1 plus 3 is 2. So you have 2. Okay. And then from 3, you have 3 plus -1 plus 3. What is it? 3 3 plus 3 minus 1. So I think it is 5. Okay, you have 5. Okay, so understand? Do you guys understand this? I hope you guys understand. Understand or not? Can you respond in Google Chat? Understand? Okay, so you guys can try. You guys can try this one. This one is complete. Okay, complete with at the back here, okay. I just want to save time, okay. So next we go for, what is this? This is a ramp function, okay, a ramp function. Okay, function that changes linearly before or after some time. So you see the word here, before or after some time. So you need to see there is before, what is the function, and what the function after that. I mean, what is the value after that, okay? Or is multiplied by function that changes linearly. So is ramp function is obtained by integrating the unit step function, okay? The ramp function. How you obtain is actually this ft equals to integration from 0 until t unit step function, okay. This one is unit step function. So this is an example of the ramp function, okay. A ramp function, you guys can see t minus t naught. So it is shifted by t naught, means it is delay, bring to front, okay, at t naught, okay. Then after that you have t naught plus 1, okay, this one, because initially, okay, let me show the drawings now, okay. If I go a bit fast, please tell me. Okay. So this is the standard, the original ramp function, okay, the original ramp function, okay. Start from 0, okay. So you have 0. So if you have 1, here will be 1. Okay, this is original without any signal operation, scaling, inversion, shifting, whatever. Okay, but let's say if you have amplitude scaling by 6, for example. So amplitude scaling by 6 means this one will be 6. Okay, example, okay. So we forget about that. So this one, let's say we assume this is 1. Okay. We also get this signal, ramp function. It's actually we get it from ramp ramp t is also equals to t ramp unit times by unit function, a unit step function, okay. So maybe let we separate this part first. They say this one is A and this one is B, okay. So now we see the A first, okay. If you notice, let's say xt, okay, x equals to t. Maybe I use y, okay, so that you will relate to your secondary school. Okay, you say y equals to t, means this one is actually related to y equals to mx plus c. Okay, so if you see here, c here is 0, so that's why it is start from 0. Okay, start from 0, and then it is a positive gradient, because you see positive, okay, positive 1, positive gradient. So it is, this is y equals to t, okay. So this is the graph. And second graph, which is b, unit step function. Okay, now we consider the b case, b, okay, original also, but it start from here, then from here, okay. This is 1. Okay, how we get the ramp function is that we multiply, okay. You see here, everything multiplied with 0 will become 0, am I correct? Everything multiplied by 0 will become 0, okay. T times b, a times b, so it becomes 0. So you have 0 here, okay. And after that, everything that is multiplied by 1 will be, you will be getting that number, we get the number back. I mean, when you everything multiply by 1, you will get the same number as the original. 1 times 1, 3 times 1 is 3, 4 times 1 is 4. So that's why when we multiply at this stage, it is like this. So indirectly, actually, you actually obtain the ramp function. So if the question later on asks you about TUT, you should know that TUT here is actually ramp function, okay. Ramp function, you should be able to differentiate, okay, because question can be tricky, okay. So if your basic is not strong, and when the student when question maybe problem, okay. Okay. Okay, that is the ramp function. Now we go for the impulse function. Okay, the impulse function, I think you guys study also in your secondary. Okay, you have this F equals to mv minus mu over t. Okay, mu over t. So this is impulsive force. Impulsive force, is it happen during very short time or after some time? Impulsive force, is it happen in short time or in normal time? I mean, in just Yes, correct. Okay, those the answer correct. Short time, yes, correct. Short time. Why I suddenly discuss about physics here? Because I want to relate with our impulse. Okay, I want to relate with our impulse. If you can see, impulse here is very thin. The width is actually t minus this constant over 2 and t plus constant over 2, and this constant is actually closing to 0. So we, so you see it is very thin. The width of an impulse is actually only 1. Okay, you see here impulse. So this is not the original impulse because it is time shifted. It's not, it is time shifted. The original should start from 0. Okay, so this is your impulse without any signal operation. Okay, so this is the properties of unit impulse function. Okay, don't worry if it's not clear. Okay, this is the property of unit impulse function. um, let's see. I don't think you have to remember this. Okay, we engineer normally we use only. Okay, so you see here an impulse. Okay, an impulse with a time shifted of t naught is actually a differentiation of the unit step with a time shift. Then you will get an impulse. Okay, then this one is just like we discussed just now. Unit time. Okay, you see this integration of negative infinity, because you see it is continuous. Unit step is continuous, then until t, then this is time shifted. Okay, the rest. Okay, and then you see here a bit special property only to impulse, because impulse you see very thin. Impulse inversion and without time inversion the same. I think it's logic, right? Because you see, it's just like an arrow, like very slim arrow there. Okay. Next, we go to this rectangular function. Okay, rectangular function. Okay, rectangular function, by the word is already clear there, is a rectangle in shape. So, but bear in mind that it is one unit. Okay, one unit in width. So if you have negative, if it starts from the origin, mean the width is extending for negative half until half, and of course the amplitude is 1. Be mind okay, bear in mind this is the way you write. Okay, if it's rectangular function, you need to write rect. If it's ramp function, you need to write ramp function. If it's with inversion, scaling, or shifting, whether in the time or in the amplitude, you need to write here as well. For example, this one, for example, you can write 2 rect, means that negative half, half, and this will be your 2, maximum magnitude at 2. Okay, I think this one is also understandable. Okay, you can relate with the graph here. Okay. Okay, this one is a triangular function. Triangular function, as the name apply, it is a triangular in shape. Okay, so has a unit value for its height and area, but not its width. Okay, So defined by this, if you see they are using modulus. Modulus means they are not considering the the value. They only consider the magnitude. For example, if we have modulus, I think some of you, or maybe all of you already familiar with the concept of modulus. Okay, if you have 3, modulus 3, doesn't mean it is positive 3, because this one can be what? Can be negative 3 and can be 3. Okay, the modulus is actually make the number always positive. Okay, so if you see here triangular, the rest of this value, whether it is modulus t greater than 1, but if you break this modulus out, you will have t minus 1 and t, sorry, where is my screen? Okay, so if you open this t, it will be what? It will be like this. Okay, so this one can be 1 or negative 1, right? So it can be t minus negative, less than negative 1, then you have t equal or greater than 1. So that's why in the triangular, okay, the triangular just now, all those after negative 1, okay, and all those after positive 1, they are all zeros except for here. Okay, and then the upper part, and the upper part of this here is 1 minus t. So you actually have two form also, whether it is 1 minus t and 1 plus t. If you have 1 plus t, if you compare with y equals to mx plus t, 1 plus t will be here because it's a plus, positive gradient. But if you have 1 minus t, you have a gradient here, which is negative. But all of them will be cut off at 1. Okay? Okay, the next is, where is? Okay. We will do later on tutorial, okay? This one later on, okay? Okay, next is triangular. Okay, next is a sine function. Sin function is actually sine t plus t. Okay, so it is obtained from the Fourier transform of the unit rectangular function. Okay, is a unit of rectangular function. So let's say now this is Fourier transform. Okay, but defined by this one. Okay. Okay, this is the original what we call sinus function. Okay, sine. Okay, but later on, okay, if you do the sin t equals to sine t with the t inside, you will see that you will get a graph look like this. Okay. Okay, so this is the sin function. Okay, here. Okay, you guys can experiment it if you want. Okay, so this is the sin graph. Okay, so if we try to do it, maybe I need to press calculator a lot. Okay. The next is a time system. Okay. Uh, sorry. You guys can wait for a while. Okay. I give 5 minutes. Okay. You guys can go to toilet. We continue at 12:30. Okay. 12:30. Don't leave, but 12:30. Continue. Okay, welcome back. Welcome back. I hope you guys still there. Okay. We will. Okay, here. Now we go for the type of system. Okay. If I'm a bit if I'm too fast, please let me know. Okay. If not, then it's okay. But don't worry. This is recorded live lecture, so you guys can always refer later on. Okay. So type of system, okay. System can be classified depends on how the system interact, okay, with an input signal. So you know, right, when in signals and system, we have input and we have outputs. Okay, then you have in the middle is the one that going to perform the transform. Okay. So several classification, whether we know about whether it is a linear system, whether it is a time invariant system or not, whether it is a memory or memoryless system, or whether it is causal system or not. Okay. So next, okay, here, system if is linear if it's meet the following two properties, which is the additive properties and scaling or homogeneity properties. Okay. So you see here additive properties. Okay. If input x1 will result in output of y1t, and if input of xt resulted in output of y2t, if this system is linear, x1 plus x2t should result in y1t plus y2t. Okay, is it clear? Means if it's system is linear, if you add something, the output will also have similar addition effect, something like that. Okay. Second is scaling homogeneity properties. Let's say input of x1t will have an output of yt. But if you multiply with a constant, okay, which is like here, scaling, so you will have an output, okay, in proportion with that scaling as well, which is k. Okay, so additive and scaling. Make sure you remember this property. Let's say, you know, question asked in exam, or I'm not sure, ask about this. Okay, is this system linear or not? You need to able to say yes, it linear, but let's usually yes alone is not enough. They will want you to support your answer. Okay, so you can say yes, it is linear because it obeys the additive properties and also scaling properties, for example. But if you want to get a complete mark and to get to sure that you score the mark, why don't you just write together this one as well, s1t blah 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 and kx1t. Okay, so these properties can be combined to yield superposition properties. Okay, superposition properties, I'm not sure. Do you guys already study circuit theory? Do you guys already study circuit theory?
Yes, yes, doctor.
Do you study superposition in circuit theory? Do you guys study superposition in circuit theory? I forget. Because I am from School of Electric, we study superposition. But I'm not sure biomedical students study or not. Oh, okay, you guys study, okay? So you guys study superposition. So this is the same. You see, superposition system is linear if it specify the principle of superposition. So let's say later the question asks you, is the system linear? So you need to have able to answer in this containing superposition, containing additive, containing scaling, okay, in your answer. In order to get, for example, it can be 5 marks of question, you know, can be 3 marks, but it's big, okay, because it's big. But if you're able to elaborate, but you only say, if you only say yes, it's linear, but no explanation, maybe you get only half mark or 1 mark. Okay, next we call this is a time invariant system. Okay, Also called as time, also fixed system, means will not change. Okay, will not change. Okay, I not means that it is cannot change at all, but later we proceed. Okay, a time shift in the input signal results in identical shift in the output signal. For example, if you have input xt with an output of yt, okay, and then therefore x t minus t naught, okay, with a time shift there, will result with an output with the same time shifted. Okay, this one is the next question is the exercise that I give to the other section. Okay, which should be answered by you also. Okay, when I share the lecture note later on, I will share the lecture note in the forum. Okay, why I choose forum last semester, I don't use forum because if I use forum and I teach the lecture note there, student can ask question if they don't understand and I will be able to answer. And if, for example, Aulia asking question and I answer, Vilina, Florent, Azara, Chintong, Necheng, Hisham, all of you can see the question and answer. Maybe you don't think of that. So from you don't know what you don't know, at least you know what you don't know. Okay, it's better. Okay, so that's why I use forum to put my lecture note, so you guys can comment. But this time, your lecture note will come with question. So how about YT to TX system? Okay, this one I ask you guys. Okay, please search for this. Okay, time invariant system I explained, but how about Y equals to TXT system? So what is your complete answer? I want to see first, okay? So this is the exercise from the lecture note, okay? Next, memory and memoryless system. So you can read this one, okay? It's a bit, maybe a bit pening, headache, confused, but never mind, read slowly. I want to go to example. Memoryless means doesn't have value. Okay, the output doesn't subjected or doesn't depends on the value before or after the time. Okay, before or after the time. So the output is function of the input at only present time. So if you see here, this is R. What is the R? What is the capital R here? What is the capital R here? You guys can answer? Chintong, are you copy paste Fatan answer because with question mark? Okay, so okay, so R here is resistant. Yes, correct. If you see here, resistant is constant value, right? Resistant is constant value. It doesn't respond with, it doesn't change with time. Normally, I don't know if your teacher teach you. Okay, I don't know. I really don't know. Okay. If we use R, this one is means like this is a constant. But if you have something R like T like this, okay, maybe the resistance change. Okay, something like that. Okay, I'm not sure if they teach you. Okay, I'm not sure they teach. I really not sure if they teach. You see here V small and T, and you have IT. But if you say if it's maybe changing, the way we write it, this is not change. But if it's changed like this, write it small. Okay. If it's not changed, it's current. But if it's changed, it's IT. Anyone teach you this or not? Or is it me? I don't know. But this is the way to write. Anyone? The lecturer of previous semester teach you guys like this or not? Circuit theory, I don't know. Circuit theory. Okay, good. Okay. Because I didn't teach circuit theory, so okay. Chintong, Chintong, do you study circuit theory or not? Because I will ask you later on. Okay, I will ask you about the slide. I will ask you slide and some Chintong later I contact you, okay? Because I am the coordinator for circuit theory, but I didn't teach circuit theory. Okay, I am the coordinator for UTM program with the Taiwan University. Okay, I want to get the I want to get the lecture note and also the slide. I have my own, but I want to see if you have different collection. Okay, where is it? Oh, okay. Oh, who have the slide for circuit theory other than Chintong? I will ask Chintong, but I can ask somebody else as well. Who else have the slide of circuit theory? Jiawan, do you have circuit theory? Okay, Kai. Okay, Kai. Kai and Chintong. Okay. Note and exam question. Okay. Defa also have. Okay, thank you. This is to help other students. Okay. For me, I only have for circuit theory. Okay, we go for circuit theory a bit while. So I only have this one. Okay, I'm not sure if you guys have. I only have this one, and I only have this one. Okay, I have this one slide like this, but I'm not sure whether this is the problem with lecture. If you don't teach, you don't do correction. So I don't teach, but at the same time, I am the coordinator for this course. Okay. So this is all your memories, right? This is all your sweet memories. Yes, it is archived, but if you already save in your local drive, I want it. Okay. Okay, Defa, I pick name Defa, like Kai, I will Kai and also Chintong. Okay, I will contact later on. Okay. So now is the memory. Okay, memory by the word says memory. Okay, means the value output depends on the value of before and after. Example here, inductor and capacitor. Okay, inductor and capacitor is dynamic system because the output depends on the past history of input. Okay, you need some value of inputs. Okay, capacitor inductor can provide it, and it influence the value of output because inductor and capacitor store something. Okay, inductor and capacitor store what? If you guys can answer me. Inductor and capacitor, they store what? Only you will answer? Welcome, okay. Let's see your answer is correct or not. Okay. What else? What else? Only two? Inductor and capacitor, they are storing what? Only Yue and Wei Kang answer question. And the rest what? Don't know, forget? Forget? Oh my God, you don't tell me you forget because you you study this maybe last year, only 1 year. For me, it's like 15 years. For me, it's 15 to 16 years. Don't tell me you forget. What inductor and capacitor, they are storing what? At least Yue and we can answer. The rest you don't know. You don't know what is inductor and capacitor? Okay, Junet answer there. The rest don't know. The rest what? Huh? The rest please answer. The rest please answer. Don't worry if you get wrong, okay? To get wrong in lecture, class, everything okay. But be sure don't make mistake in test and exam and quiz, that's all. Okay. Okay, some answer there. The rest don't know. Maybe the rest they didn't know what is inductor and capacitor. Okay, general answer for both inductor and capacitor. General, you have general answer, then you have specific answer. For inductor and capacitor, the general answer, they are storing energy, both of them storing energy. So the answer correct is energy. The second question will be more specific. What is energy that is being stored by inductor? What is energy that being stored by capacitor? Can all of you answer this? What is energy stored? What type of energy stored by inductor? What type of energy stored by capacitor? The first question just now, the answer is energy. Store energy, that's it. Capacitor and inductor, they are storing energy. Second question, what type of energy stored by inductor? What type of energy stored by capacitor? Some more answer? Doesn't mean you are wrong. I just want to see all many students try to answer. Okay, don't worry you get it wrong. Okay. Yes, nature inductor. No, doesn't mean that you're correct. Yes you answer for inductor, but how about capacitor? Capacitor store energy in the form of what? Okay. You guys just studied this last year. Okay, for inductor, it store energy in terms of magnetic. Okay, magnetic energy. And then capacitor, it store energy in the form of charge. Okay, electrical charge. Okay. So you guys can see, now you can see. Oh, I remember on the okay. Yes, Satya, but not magnetic. Okay, magnetic field. Okay. Now we go for causal system. Causal system is the output at any time depends on the input only for t less than t naught. Okay, and does not depends on the value of input for t greater than t naught. Okay, this is causal system. Causal system. Output only depends on the input only for the value that is less than t naught. Okay, less than t naught, and does not depends on the value after. Okay, means that output only exists after an input was applied to the system. So we only have the output after an input was applied to the system. So if you see here, this is causal system. Okay, this is your output, right? This is your input. Okay, so you only have output. Okay, if you already have input which is applied to the system before that. So here this is what? This is -2. So this is happened before. Okay, so this is causal. Okay, this is non-causal. Okay, this is non-causal. Y-active because this one is the input. This one is after. You see, this is a delay. Okay. Sorry. This one is -2. Okay, this one is delayed because we should have input before it. Okay, we should have the input before it. This one is xt -2 means this one is time advance. So this one is non-causal, okay? Because causal, causal is in causal system, output only exists if the input was applied to the system. So there will be a bit delay, okay? So this is causal, okay? Causal. Okay, finish. And then we will settle this in class, okay? We will settle this in class. Or maybe I will share, I will share this in the e-learning, okay? I will share this in e-learning. You guys can solve before the class tomorrow, or you guys can solve in the class, but I don't know. But I will give shorter time in the class. Short time during class means you guys need to share your answer in Padlet. Okay. So I will take this. I will share this. Maybe Chintong will remind me later on. Okay. I will give later on after the class. Okay. And for the tutorial tomorrow. Okay. For the tutorial tomorrow. Okay. And then for your quiz, I don't actually write. I don't have the quiz yet. I mean, I don't write the. I don't prepare any quiz yet. Question for the quiz, but most likely it will cover like week 1 and week 2. Means so be prepared. Okay. I didn't tell this to session 3 yet. Be prepared. Okay. Never mind. I will inform later on. I will inform on the tutorial. Please ask me, okay? I want to be fair with section 3. I didn't inform them yet. Please ask me what kind of quiz. But for the quiz, all of you will... I don't know. I don't know who have problem with e-learning access or who doesn't. But my quiz, okay, all the quiz, most probably, I'm not sure. But for now, I plan for it to be all in quiz. I mean in e-learning, because there is high number of students here. I think if I mark a bit terrible, okay, a bit. I mean there will be more delay. So if I use quiz in e-learning, you will get you will get the answer directly of your results, and I will also get the answer directly without having to mark manually. But test, nothing I can do. I will mark manually together with final. Okay, final we plan to do team marking. So I maybe, let's say you have final 5 question, maybe I in charge only to mark 1A to 1B, for example. So the other question will be marked by other lecturer. Okay, so whether I'm considered lenient or strict last semester, the effect will be a bit fair to all of you, because now my skill in marking is only certain type of question, not all. So it will be fair to all students, means the question will be marked by all lecturers. Okay, that is what we agreed last time. So if you change section just because you want to escape the lecture that you think that is strict, no point, because now we are doing team marking. So no point of moving to my section and using clash as the excuse. Okay. The quiz will be 5 question, 5 marks. Okay, 5%. So it's big. Okay, because it is about half of your test. Your test will be 10%, but your quiz will be 5%. And I will not be like 100% cruel. Okay, let's say one question 1% will be not I mean in the sense like, let's say if you answer 1A is correct, 100% mean you get 1 mark. But if you answer B, maybe you get 0.5%. Okay, if you answer C, maybe you only get 0.3%. And if you answer D, D, for example, A, B, C, D is the total false, which is 0. So all of the question they will have mark. Do you guys understand me? I mean, I will not create like 1-0. I will try to have some, transition. So because this will compensate, with the manual quiz, because manual quiz, even if you get answer wrong, but solutions still have some mark. Am I correct? But quiz, you cannot do that. Quiz multiple option, you cannot do that. Okay, one of the way I try to have later on is that you will have you have some total complete correct answer, some will be not so correct because the answer is wrong, but the method is there. Okay, something like that. But it is multiple option, only A, B, C, D. Okay. So with that, we finished the lecture. Okay. See you guys. When is the next class? Huh? So the next class is at when is this? 9. 9. The next class is 9. Okay. Okay. 9 a.m. Okay. So thank you, you guys, for helping Chintong. Okay. And those that want the book, okay, please give the name to Chintong. Okay. I think I will. Where is the lecturer? Okay. Please. The name. Okay. The name. Okay. But I'm not sure. You guys not in UTM, so I don't know. I really don't know how. I'll get the name first. Okay. And later on the price. Okay. Okay, with that we finish the lecture. All the best to you guys. I want to rest. 2 p.m. I will have another meeting, so see you tomorrow. Okay. I will share the lecture note soon. Okay, I will share the lecture note today. Okay, thank you. See you guys.
Thank you, Doctor.